I want to introduce you to the idea of using graph apps to develop or help to develop your apps running on a mean stack. We are a company that runs a commercial service in the coffee area, in the coffee business, which helps coffee roasteries worldwide to organize their inventory of green coffee. It's quite important for them because if they run out of the green coffee, they can't sell any products, and green coffee takes a while until it's shipped to you, so you have to order in advance. So that means you want to know when to order, and you're running out of a certain stock of coffee. Now our customer base is quite diverse. We have very small and very large users or customers, with some with several warehouses, and this diversity and is reflected that our app needs different features for different user groups, and we keep on developing this app and wonder how are our users using this app, which features they understood, which features are used in which region of the world from which customer group. So we start adding and changing features and experimenting with this, and the users, as they use our service, they leave footprints in our database. And now we could, of course, run queries or develop a management dashboard that shows us in a graphical way, for example, some KPIs, and to give us a better understanding how our system is used. But that is very time-consuming. It's slow. The management has to inform the development department what they want to see. They have to develop, and then the result might not what they expected. So there's a cycle which is slow and costly. And I wonder if it's possible to do that a little faster by using off-the-shelf tools, and instead of running queries, having a tool that helps you to explore the data in an interactive way. And there I discovered this graph app SemSpect, which is running on Neo4j, which looked exactly like I wanted to have. So you can navigate and browse through your data, and basically discover facts and structures in the data. And now our system, like many others, is implemented on the mean stack, which is basically on the lowest layer you have a MongoDB database, which is not a graph database, which is a document-based database, which we use via an object relation mapper, mongoose, to store objects from our software, which is implemented in JavaScript or TypeScript, and layered on top of this data layer is then an UI system. We use Angular, and this stack is often used in this way by companies like Netflix or others. But as I said, to see really the structure in the data, you have to write all these in part complex queries. And now. Yeah. I saw this SemSpect, and Thorsten is just scrolling on the SemSpect demos here, and can quickly give you an impression on what that tool can do for you. But it's running on Neo4j, but my data is in MongoDB. Come to that in a minute.
Exactly. Yeah. Thank you, Marko. SemSpect is a graph visualization and analytics tool that comes as a Neo4j plugin, as well as a system for RDF graph data. You can find a couple of demos on the web page. Here we have the Panama Papers, for instance. So that's the SemSpect UI. You see the list of classes on the left-hand side. This demo is working on RDF data, but in case of Neo4j would be just the Neo4j labels. And what you can do, you can drag and drop one of these classes or label into the main visualization. Then you see a group of more than 800,000 entities. It doesn't make sense to show them all, but you can look at the details if you want. So you can just click on it, and then you see all the tabular data of these 800,000. And if you click on this triangle icon here of this group, then you see all connected classes to this group of entities. So these entities are related to addresses by this relationship, to other entities by this relationships, and so on. And you can just select one of these, and then you see that these entities are related to 76,000 addresses. And when I now go here and say, okay, let's just filter this down to the entities from Germany, then you see there from these 800,000, there are just 214. And when I apply this, then this entity group gets filtered down, and you see that the filter propagates through your graph, and you see this gray dots, which are individual data objects in the graph, and you immediately see that there's one address in Kiel that is related to 21 entities here on the left-hand side, which is an interesting finding, and could also be something in the data Marko just mentioned. So as Marko already said, that's SemSpect on top of Neo4j, but his data is in Mongo, and it needs some mapping from one database to the other, and that's what he developed.
Yeah, so in the first place, I thought, oh, that's splendid, because MongoDB is based on JSON and can of course export JSON data, and I found that this Neo4j can import JSON data. So first I tried that way to export into a file and then import that file, but was running in a lot of difficulties, because the JSON that MongoDB is generating is not a standard JSON. It's enriched with type information and object information, and then also on the other side, Neo4j was not flexible enough, basically. So I had to write some scripts to massage these files to make that work, and was still disappointed by the information loss that resulted through this conversation. So then I started, when I anyhow have to build a script, I started to build a script which directly communicates with the MongoDB database system and Neo4j. On the other hand, other side, there are Python connectors to both systems, and I wrote a script that basically takes the object structures of MongoDB and turns them from collectors, turns them into nodes and relations on the Neo4j side. The script is open source. It has the GNU license. You can use that. It's on GitHub. It has is well described there. It has a certain number of configuration options, which you mostly need to specify how to find the MongoDB database and where's the Neo4j database running. And there's a few other options which you can use to treat or to tweak a bit the generation of the data, the mapping. Exactly. So then the repository also contains an example dataset or rather a generator for data, which is also described in the wiki of the GitHub page. There you can just generate a dataset which is about products and customers, and yeah, you see it here. Thorsten is just browsing that one. And then you can use this one to test this transformation from the MongoDB towards the Neo4j. And then the example also describes how you set up both systems and how you then start the SemSpect and start to navigate.
Exactly. I can say some words about the data generator.
Yeah.
I've written, so you just call this, it's a JavaScript thing, and you can configure the number of data that is generated. It simulates data from a typical web application using the mean stack, so MongoDB as a backend and object relational model on top of it. And it basically comes with this four kinds of collections: users that place orders, which consists of a quantity of products, and there also is a country's collection. And I have prepared this here before presentation. So here, that's a view for Mongo database. We have okay, let me zoom in a little bit. We have a my database that contains the generated data, which consists of these four previously mentioned collections. So we have orders, for instance, here, and such an order is basically a JSON document that consists of order date and an ID, a user, as well as an array of products and quantities. And you see here this object references. So that's what the object model did on top of Mongo. It does not render all the products and users into this document. Instead, it places these IDs here that refer to objects in other collections. So that's a user ID here. So if we look at for the users, then we see all the users here, and I can just search for this ID, sorry, here, and then we should probably find the user that has placed the order I showed you before. Okay, so how can we get this into Neo4j? Marko mentioned his mapper, so I will just execute that mapper here with this on this terminal, and here I have Neo4j desktop running, and already an empty database called mygraph. And if I open the Neo4j browser here, you probably know or familiar with. Then you see that database is empty. It contains no labels and no relationships. And when I start the script now, then, as Marko already mentioned, you have to provide credentials, so your user and password for Neo4j. You have to specify the Mongo database you're reading from. And there are two options here. The first one is a sublabel configuration that says, okay, for users, we have a subscription slot here that tells whether the user is a home, pro, or free user. And we would like to have this as an additional label in our Mongo graph. So we add the value of the user subscription field plus a postfix _ user as an additional label. And when there is no slot, then take the no subscription label for this user. And we have a second option here that helps.
Which adds extra relations also based on attribute values, basically. Yeah. So these objects are not linked by object links in the MongoDB, but by having literally the same value. Yeah.
So here, for instance, here we have the user collection, countries collection, and we would like to introduce a link from users to countries whenever the country string value is equivalent to the ISO name of one of the objects in the countries collection.
Yeah, this shows a paper we had on the MongoDB on the Neo4j developer blog, and describes also this example. Yeah. The link is in the chat.
So now I will start the conversion, and then you see this objects here pop up in the MongoDB, and you see here's the data. So since we're running up a little bit of time, I will just I will instantly switch to SemSpect. SemSpect is a graph app for Neo4j. You can easily install it by the graph app gallery, which is built into Neo4j desktop. So it's just a one-click installation, and then you have it here as a graph app, and you can start it, and then it opens up and reads from the Neo4j database and does a little bit of analytics. And then you see here, upsala. I need, okay, yeah, and I'm refreshing it. Then you see the additional labels here, for instance. So we have 63 free users that I can use here, and then explore the graph, the orders of these users, or the countries they're from. So the country link we have introduced by this additional option, and then go to the products, the order products, and then to the products in the end. And let me increase the threshold here a little bit. Then you see all the products here with details on the right-hand side. And you see that some of the products are ordered more than others. And let me just finalize this to filter this down to a particular category of products, let's say food, and apply this as a filter. Then you see that 120 food products ordered, and now I can restrict the previous groups, so I can propagate this filter from the leaf to the top, and then we see, okay, there are these users ordered at least one food product, and there are products that have been ordered more than others, and here we can just flag this, so that product here is used by these 5 users over these orders, and they are related to this sort of countries. And I can now just export this as a CSV file data, or save this exploration for further analytics later on. Or I can even introduce new labels to Neo4j by saying, okay, these are 3 users that ordered food, and then this label is written back into your graph database and is shown here. So you can not only analyze your data, you can also refine your graph schema while browsing, and do very sophisticated analytics, and even export this as a query, as a Cypher query for the Pro version of SemSpect.
Running a bit too long.
Yeah.
So there are questions.
Any questions?
It's too late for questions.